Okay, today we're going to talk about transformations of graphs. So 2.6 in your guys' textbooks. So the first page is just recognizing basic graphs of functions. I'm expecting you to know what a line looks like, or what x squared, x cubed, square root of x, cube root of x, the absolute value of x, and 1 over x looks like. You're going to take these graphs and you're going to be expected to transform them. Now, Alex a lot of times will give you a basic graph and then say, transform it. You know, if I replace x with x minus 3, how is that going to transform the graph? And on Alex, you click up the graph and you move it over 3 points. So it's pretty, you know, it's like, okay, I'm going to move it over 3 and up 2. There's a little disconnect when you actually go, and if I say, you know, here's a graph of x squared, or here's x squared, now graph x minus 3 quantity squared. So you have to know what original x squared looks like to be able to then say, I'm going to shift that to the right or left or up or down, or squeeze it horizontally or stretch it horizontally, squeeze it vertically or stretch it vertically. Okay. So I'm assuming you know the basic graphs, and at the end of this lecture, they'll just be a quick match, being able to say, this is what x squared looks like, this is what x cubed looks like, this is what the square root of x looks like. This is what the absolute value of x looks like. This is going to come in handy when you have to go to place a graph in Alex, or when you have to do that on your written homework or on your written exam. You want to grab a handout? Okay, so let's just kind of get started with applying. The first thing we're going to look at is a vertical and horizontal shift. Okay, so if you're given a function here and you rewrite the function, instead of f of x, you have f of x plus k, that's going to shift the original function k units upward, right? You can kind of think of it, this is affecting the y. For every y value, you're replacing that with y plus k in a sense, right? F of x plus k is your new y value. So it's going to shift it up. If k is negative, it's going to shift it down. So here the manipulation is not on the x, so that's going to be the vertical up or down, right? It's the most straightforward. K is positive, it goes up. If k is negative, it goes down. It gets a little bit interesting. Anytime we manipulate the x, it's counterintuitive to what we think. So if I replace x with x minus h, it's going to shift the original graph to the right, right? You think, oh, negative, but it's going to the right. F of x plus h is going to shift the graph to the left, right? It's kind of like you're undoing what you're doing to it. So let's just look at a quick example here. You have a graph. This is kind of what you'll have on Alex. This might be a screenshot from Alex. And it's saying this is the graph of the original function, x squared. Now I want you to graph x squared plus 3. So all these points in the graph, we're replacing that with x squared plus 3. So this point here, 0, 0, that's going to be shifted up to 0, 3. The x doesn't change. If x is 0, then when I plug 0 in here, I get 0, 3. The y is changing. The shift is going to be a vertical shift, right? So then all these points go up 3 units. So I shift this one up 3, this one up 3, this one up 3, and so forth. Does that make sense there graphically? Here, this is a combination of some things going on here. I'm shifting the graph. I'm replacing x with x minus 3. So that tells me I'm going 3 units to the right, right? So this x is going to be changed 1, 2, 3. The y is going to be changed 2, 1, 2. It's a minus, so if we look back on the, yes. Well, the absolute value is not what gets you. It's if you place it with the minus, it goes to the right. Anytime you're messing with the x, it's going to be counterintuitive to what you think. You see how here, this is messing with the y. I'm not changing the x. It's messing with the y. So I'm going to go up because it's plus. If it was negative 3, I go down. But I'm dealing with the y, so I'm changing it in terms of y. Here, this x was originally absolute value of x, but now its absolute value is x minus 3. So the -3 tells me to go to the right 3. The +2 tells me to go up 2. So I've only moved this 1 point on the graph, but if I wanted to shift the whole graph, I might want to pick 2 more points to move. So I'm going to take this point here, and I'm going to shift it to the left 3 and up 2. So this new point goes 1, 2, 3, 1, 2. So that new point's there. And I can take another point over here, and I go 1, 2, 3, up 2. So this is all a line. So I need to connect these 2 points, and I need to connect these 2 points. Right? So this point is going to this point, and this point is going to this point. But being able to graph it, all I have to do is get the interesting points and then just connect the interesting points. Here, the main interesting point is 0, 0. And then I can pick any of these others to translate. You guys see that? You guys dealt with this before? +3, -3, know how to manipulate that. Another example here, they might not tell you what the graph of the function is. They might just say, let's call this graph f of x, or h of x, or k of x, or p of x, or anything they want. So they're saying this is h of x. Then they're replacing, everywhere there's an x, they're replacing it with x minus 3. So that tells me I take every point on this graph and I shift it to the right 3 units in terms of the x direction, right? Because it's messing with the x. So I go 3 units to the right, 1, 2, 3. So this new point is now 3 minus 1. I didn't change the y value. And then I can just kind of rough graph it. There's not any really interesting points, it's just increasing. You could take one here, this point here, and shift it over. 1, 2, 3. So then I connect those the same rate and get a graph that looks like this. We haven't talked about reflections yet, so be careful. If they give you something like this, this is minus x cubed. It's already minus x cubed. So then I'm replacing the x with an x minus 1, and then I'm adding 4. So what does the x minus 1 tell me to do? Shift it to the right 1 unit, and the plus 4 tells me up 4, right? So I can take this point 0, 0. I go right 1, up 4. So now this new point is here. I might take another point on the graph. Be a little careful because I want it to still be on the graph. So I may take this point here. That is minus 1, 1. So I'm shifting it to the right 1 and up 4. So it becomes here. I can take this point 1 minus 1, goes to the right 1 and up 4. So then I can kind of connect these the same, see if I can get it to be the kind of the same form. I have a lot more of the bottom graph showing, but you guys see how that's kind of done there? On Alex, it's a little more intuitive because you can actually see the graph, move it over 2 and see the graph, and move it up 4 and then see the graph and click there. Key thing is to remember the x moves counterintuitive, but the y is going to move up if the k is positive or down if the k is negative. And then there's vertical and horizontal stretching and shrinking, and it's going to be along the same lines. The y the y manipulation is going to work just like you think. If it's multiplying by 2, it's going to be stretching it. If it's multiplying by 1/2, it's going to be shrinking it in the y direction, sorry. That's going to be straightforward. The x is counterintuitive. If I replace x with 2x, then that's actually shrinking x by a factor of 2. If I replace x by a half, that's actually stretching it. It's kind of, again, counterintuitive, right? Just like when I have x minus 3, I move to the right 3. Right? If I replace, and let's just kind of look at the notation the book goes over. If I take a times f of x, if a is greater than 1, it's exactly what I expected to do, and it's stretching it. 3 times the function, right? Y equals 3 times the function. If my y went from minus 1 to 1, all of a sudden it's going to go from minus 3 to 3, stretching it in the y direction. If a is less than 1 but greater than 0, because we don't want to deal with a negative yet. So if it's a fraction less than 1, then it's going to be shrunken vertically. If I multiply it by 1/2, if it's going from minus 1 to 1, and I multiply it by 1/2, all of a sudden it's going from minus a half to a positive 1/2, right? So it interacts pretty much like you'd expect. You're only ever dealing with the y, though. The x stays the same. You're not manipulating the x in any way. So your range stays the same. Your domain is what's changing. And it changes pretty what you would expect. However, when you manipulate the x, just like we talked about before, it's going to be counterintuitive, right? If a is greater than 1, it's going to be shrunken horizontally. So if I multiply it by 2, I've changed the domain. If it went from, let's say it goes from minus 2 to 2, and then I replace x with 2x, it's going to go from minus 1 to 1. The y stays the same, though. The domain that's changing. And that's kind of what they're trying to get at here, in this case, is if your original range went from x to y, your new range is going from x over a to y. So if a is less than 1, then you're going to have you're going to shrink it. If a is greater than 1, you're going to have a shrink. If a is in between 0 and 1, you're going to have it stretched. And I'll show you some examples. The next two examples are examples they usually put on the exam because it really shows, do you understand what's going on here? If I want to change, this is the original graph, f of x, and I want to graph f of 2x, right? So everywhere I have an x, I'm replacing that with 2x, and I want to find my new domain. This is a horizontal shrink, horizontally, so I'm only dealing with the x here. The y's are going to stay the same. So my lowest point is minus 2, and my highest point is 4, right? But I have to do that over a period. Instead of minus 4 to 2, I'm going to go from minus 2 to 1, right? Because I take my endpoint, minus 4. What's minus 4 divided by 2? It tells me minus 2. So this point now, instead of it being minus 4, it's minus 2, but the y point stays the same. So I'm still going to be minus 2 there, right? At minus 2, I was 4, but if I plug minus 2 divided by 2, that tells me at minus 1. At minus 1 now, I'm 4. At 2, originally I was minus 2, but I need to find what 2 divided by 2 is. That's 1. So at 1, I'm going to be a minus 2. Your y output stays the same. It's just the x that has to change, right? So you see how I divide it by a to find my new x. So original x was minus 4. My new x is minus 2, but my y stays the same. Does that make sense there? Well, let's do the next one. Very similar. It's the same function, but instead of x, I'm replacing it with 1/2 x. So now my original x is minus 4, but I want to find what my new x is. I take minus 4 divided by 1/2. So that gives me minus 8. So my new x is minus 8, but I just have to see what it is at minus 4. It's minus 2, so minus 8, comma minus 2, right? So I take the point minus 4, comma minus 2, and that gets transformed to minus 8 minus 2. Because I'm taking the x point and dividing it by a. So when I divide it by 1/2, that's really flipping and multiplying by 2. So do you see when you replace the x with a number less than 1, it's actually going to stretch it. horizontally. And when you replace it with a number greater than 1, it actually shrinks it horizontally. And to find the corresponding point, you say, okay, this is an interesting point. I want to see how that's being transformed. X is minus 4, so my new x is going to be minus 4 divided by 2, which tells me minus 2, but then it's the same output, so I put a point here. So this point gets transformed to this point. This point gets transformed to this point, and this one gets transformed there. And then I connect those dots, and that's my new graph. Right? It's the same thing here. This point gets transformed here. How does the negative 2 point get transformed? What's it go to? Very good. Goes to negative 4, and then negative 4, the output at minus 2 is 4, so the new output at minus 4 needs to be 4, right? So this point gets transformed there, right? And then this last point, 2 minus 2, what is the new point on the graph?
4 minus 2.
Is it 4 minus 2? Very good. Connect those 2 points. Oops, got a little off there. If you notice here, the range was from minus 4 to 2, and now it's minus 8 to 4. The range increased by a factor of 2. The domain did not change at all. The domain's still the same. The lowest point to the highest point is still the same. Any questions on that? We'll do an example where the domain stays the same, but the range changes, right? So anytime you're messing with the x, you're messing with the domain, the x values. You're not changing the range values necessarily. You can do both. Here's an example before we talk about reflection. Here would be an example of 1/2 f of x. So in this case, I'm not changing the domain at all. I'm going from 0 to 4. So 0, 0 is going to be 1/2, 0, 1/2, 0, which is 0. Right? So these 2 red points aren't going to be changed at all, because 0 times 1/2 is still 0. So this is the only other interesting point. I don't change 2, but if 2 outputs to minus 4, then what would 2 output to 1/2 minus 4? Which would then be minus 2. So the red graph here is 1/2 the blue graph, right? So the domain did not change at all, but the range, the 1/2, shrank it vertically, which is exactly what you'd expect 1/2 a function to do, right? But f of 1/2 x is going to stretch it by a factor of 2. F of 1/3 x is going to stretch it by a factor of 3. Right? So another thing that we can do, we've only ever talked about positive a's, right, out in front, but you could have a negative sign out in front or a negative within the parentheses. If you have a negative out in front, that's going to be reflected about the x-axis, right? If you had a positive x value before, x value, x comma y, if your y value was positive and your x value is positive, and then you're changing the y value, you're reflecting that about the x-axis. So this is an example here. If I have 2 comma 4, the 2 stays the same, the input stays the same, but the output becomes negative. This is y equals minus f of x. I don't change the x, I'm changing the y. So the x stays the same, the y is being multiplied by a -1. So I reflected about the x-axis. So if the blue function was my original function, and I say what is y equals minus the blue function, I would get the black function. If I have y equals f of minus x, if I replace the x with a minus x in parentheses, that's a reflection about the y-axis. That means for every input that's a positive 2, I look at the output and put that output at -2, right? So here, this is 4, 2. Then the new output would be -4, +2. The y stays the same, but I flip the x value being positive or negative. Here, the x value stays the same, and I flip the y value being positive or negative, right? So let's look at this example here. This is a good example because it's not typically like, oh, I can just flip it about the x-axis or flip it about the y-axis. I have y equals minus f of x. So that tells me it's a rotation about the x-axis, right? What this means, if I have minus 6, 3, this point is minus 6, comma 3, the new point is going to be what? Where's this point going to be transformed to? The x doesn't change, so it'd be minus 6, minus 3. Very good. So minus 6, minus 3, minus 6, minus 3. Right, this is a line. So the 0, 0 point is going to be 0, 0. The other interesting point would be the end point, minus 2, minus 5. What would be the new point? Minus 2 is not going to change, but I'm going to change the minus 5 to a plus 5. So I get the graph of this red function. And if I could take this piece of paper and fold it over as reflection to the x-axis, this line would represent right here, right? And this line would be down here. But you can see if you can take the endpoints and reflect the endpoints, then all I have to do is connect the two dots, right? It would have been different if it was y equals f of minus x. It would have been reflected about the y-axis. So you have to be careful. What's it doing? Where's the minus at? Any questions? Here's two examples that show up on Alex. Here's a graph of a function f of x. Is shown below. Graph minus f of x plus 4. You have to be very careful with order of operations here. You do multiplication before you do addition. So you have to flip it before you shift it up or down. Right? So the first step is to find what is minus f of x. So minus 2 to 4 would then be minus 2 to minus 4. Any 0, 0 point is going to be the same when you're flipping horizontally or vertically. That point is going to change if you have any horizontal shifts or vertical shifts. 4, 2 becomes 4 minus 2. So the red is just minus f of x. Is that pretty straightforward to see there? So then if I want to take the next step to be the plus 4, every point I'm going to move up 4. So here, here, here. So this blue that's left is going to be the truly minus f of x plus 4.
So you said you can't move it up 4 first?
Correct. Because it's
here, right?
If you move it up 4 and reflect it, it does work here. Be very careful with order of operations when you're reflecting. You usually want to do if there's no shift or anything. So if you reflect it, shift, it should actually work at all times. I'm thinking flipping, shifting, shifting, and flipping. It gets really careful when you're stretching or shrinking. You want to, at what point, if you stretch and shrink at the same time, you want to be careful what you do. But yeah, here, like you said, if you shift this up, if you shift this up, it actually doesn't work. You would have to shift it about this line instead of about the x-axis. Order of operation, let's go through that real quick because that's important. If I shift this up first, I would be here. I'd be here, right? Then if I reflect it, I'm going to be down here. Because right, minus 2, positive 8 would be minus 2, minus 8. Right? So if you move the line you're also flipping about, you'll get the same answer. But it's yeah, you moved it along with it, saying, okay, here's the function, I'm moving it up, and then I'm flipping it about this line here, which would give you the right answer. But that's not mathematically what this is saying, right? So 4, 6, 4 minus 6, that's not the same thing. Make sense?
Yeah, makes sense.
Here's an example, or Alex, where they expect you to come up with the mathematical equation to the transformation. So if I have f of x and I want to get to g of x, what is going to be the mathematical equation, right? G of x is, is there any flips that you can tell? No. So I still need the minus absolute value. Is there any shift to the right or left? Right? So I go over 1, 2, 3 units to the right. So what should I replace instead of x? What should I have in here? How many people say x plus 3? How many people say x minus 3? It's x plus 3. Because remember, x is counterintuitive. If I'm going to the left, I'm really plussing. If I'm going to the right, I'm really subtracting. If I'm being multiplied by a half, I'm stretching. If I'm multiplying by 2, I'm really shrinking. Right? And then I'm going up 2 units, so that's going to be plus 2 here. I should get my red back. So really, the red line is represented by taking the minus absolute value of x, replacing x with x plus 3, and then adding 2 to it. So every point can be described that way. You guys see how you can go both ways? Given a mathematical expression, come up with the red line. But given the red line, come up with a mathematical expression, right? Here's kind of the summary of the transformation of graphs. Vertical shift, I think, is pretty straightforward. You're shifting up or you're shifting down. Plus k, minus k. Horizontal, anything done in the horizontal direction is counterintuitive to what you would think, right? X minus h is shifting to the right. X plus h is shifting to the left. If I have, again with the horizontal, if I replace it with ax, is a horizontal shrink if a is greater than 1. Right? And it's a stretch if a is a fraction, which is counterintuitive. You just have to go with it. The vertical acts just like you would expect, right? If a is greater than 1, it's a stretch. If a is less than 1, it's a shrink. Right? I have my y-axis, and if then I have 1/2 f of x, that's going to shrink it by a factor of 2. If I have my y and I have 2 times f of x, it's going to stretch it by a factor of 2. So just kind of a note, kind of what we talked about before, it's important that horizontal transformations are performed outside in. So dealing with maybe something that's a little more complicated, and these don't really come up, but the first thing you would want to do is replace your function with bx. Then you would want to do any shifts. So you do any kind of horizontal shrinks or reflections or stretches. And then you would do your shifts. Here's the last, just a little practice. You should be able to match these just by looking at them. You should be able to look at A and say that is the absolute value of x. You should be able to look at C and say that is x squared. E, square root of x, right? B, This is x cubed. D is 1 over x. And f is the cube root of x. Those are the common ones that kind of come up where you talk about shifts in the graph horizontally or vertically. Some of them aren't that interesting, like the x squared. If we replace that with 2x squared and we stretched it, it would look the exact same as x squared because it goes on forever, right? So sometimes they'll give you like specific endpoints. So you can see then if I stretch it as x squared, that it changes the range by a factor of 2.
The ones where there's fractions, like
Mhm.
put them in a decimal and change them.
Like instead of 1/2, put 0.5. You can, that's a little scary because points are really hard to see. And you might think, oh, this is 5x instead of 0.5x. So if that helps you think about that, I'm taking every x value, in a sense, multiplying it by 0.5. Is that same thing as, or sorry, dividing it by 0.5.
Yeah, divided.
Yeah, because you don't want to multiply it. Yeah, if you think of it, okay, I'm dividing that by a, and a is 0.5 in your calculator, that's fine if that helps. Because sometimes when you see that fraction bar, you're like, I don't want to deal with it. Yeah. So yeah, if you want to find what, if it's -4 and you want to find what the corresponding x is going to be, then you can just say, yeah, -4 divided by 0.5. That's fine in your calculator. Instead of hitting -4 divided by 1 divided by 2, because that's a little tricky. And everyone's calculator is going to be different in the way you input things. You have to be careful with that. So yeah, if you want to put it in your calculator, that's fine. So I want to take some time to look at some of your ALEX homework problems. So these are PDFs directly from ALEX. So I go into ALEX and say, shoot me a PDF of the homework problems. They're randomly generated. So yours might be, instead of x squared, it might be the absolute value of x. But along the same idea of how to go through this transformation. It might even be worth a minute to look at ALEX and see how you're going to interact with the program. Since we have a minute, you guys have gone in there and you've done the homework. Yeah, so it shouldn't be too bad. I want to see my students' view. Assignments, book, administration, students' view. And every time I go in, it seems like they want to always have me do the assessment. Enter. I think I can bypass it this time.
And it's not due until.
It's always going to be due 11:59. Yeah, the day before the test.
On mine, like when I was in Alex, I had it last semester, so automatically goes into my other class. I cannot figure out how to put it in. But what do I, like, it keeps asking me.
If you just go to Alex, like the homepage, and like go to enroll in a class, it'll ask you, do you have an Alex sign-on or not? But then you want to put that access code for the course. Let me see if I can do it without messing up my browser. So yeah, this will be your login.
I can do that, and then I type in what I had, and it comes up in my old class.
So instead of logging in, it
Still shows.
Yeah, it'll show it still, but you have.
So yeah, pretend like you don't have an access, say sign up now, put in your course code and then continue. And then it'll say, do you have a Alex sign in or not? And that should be able to add you to the class. The course code is on Blackboard. It's on your syllabus. It's on that first page. It's highlighted. You can put that in and continue. And then that should be able to add you to the class. Yeah, so if you're not seeing this course, then you're stuck in that other course. You have to put that access code. There's probably a way to do it from your login. I just don't know it.
Okay.
So just do it outside your login and then say I already have a sign in. Okay, so this is an example of the homework on, did I go in the right one? Okay, so I went into 2.3. So this might happen. It says in progress. It won't let me go into any other assignment until I go scroll to the bottom, hit done, until I submit this assignment. So I can say, okay, submit homework because I clicked on the wrong one. It tells me I didn't answer some of them. That's fine. and then it's going to give me my grade as 0. And then it will open the other, give me access to the other assignments. So if you say, I don't have a link here, it could be because you're already opened another assignment and haven't submitted it yet. So now if I want to go into 2.6, I'll give you your information when it's due, and then there's 10 problems. So here's an example of taking the graph and shifting it up 3 units, right? So just like kind of what I said, if you click on the graph, it gives you the graph. So you need to shift it left, right, up, horizontally. It will only let you do what you need to do. So I need to go up 3 units. It says, do I want it there? That's good. I submit it. The next question. You can go through and you have to do all your questions before you can submit your homework. Now working in the pie, it's going to give you feedback question by question. So this example, take the unit, shift it down 2. See if I can get a little bit different interface. So here I'm shifting it to the left 3 and up 4. So you should be able just to click on it with your mouse and drag it up. So the graph of the function is defined, is translated vertically down by 7 units. So here it's wanting to ask what would be the new graph of the function. So vertically down, so that's only going to really affect the +4. If it was originally at 4 and then I go down 7, if I plug in 0, I have 4, right? And then if I want to shift it down 7, if I plug in 0, what would I have? Very good. So I would have x, and here's how you got to put in your exponent minus x squared. So I have my original function, but instead of +4, I'm actually -3. Because really what I can say here is this +7, or sorry, -7, -7, and 4, -7, -3 there. So next question. Here's an example. They don't tell you what the graph of the function is, and you have an endpoint. So you have a specific domain and range in a case. So if I shift it to left 2 units, I have to be careful because if I move it up or down, it can change it. So I want to go specifically just to the left. Right? So here I'm doing a combination of shifting horizontally and vertically. Go ahead and see. Here's an example where it is being reflected that I'm replacing x with a minus f of x. So what kind of reflection is that? X-axis or y-axis? It's the y-axis. So the point here, actually the interface is a little different. It's going to have you mark points. So I'm going to maybe mark this point here because I know that point is on the y-axis, so it's going to stay on the y-axis. This point here is 4, 3, right? So if it reflects on the y-axis, the point is going to be -4, 3, right? So I got a little point there. You see that? This point is -4, 7, so then it would be 4, 7, right? -6, 4. So, ooh, it's not -6, sorry. -7, 4 would then be 7, 4. So then to draw this, I need a ruler. And I'm going to put my ruler at one point, and then I'm going to take it and put it at the other point, and then I'm going to draw my line connecting them. Of course, you're doing this with a mouse and you're clicking on it. So there's a little disconnect there, but if you can do it on Alex, you're going to apply the same thing on your paper. But sometimes students will be like, I don't have the ways to make my points or my ruler, so I don't know how to do this problem. Don't get too disconnected from it. It's the same thing. The tools you're using are just a little different. And be careful that you don't go above your point. See how I went above my point there? I don't want to do that, so get my point back. This was -4, 7, so this would be 4, 7. So when I get my ruler, when I draw it, I only want to go to that point. See that? I have to get my ruler for this point and this point, draw it. Makes sense there? Sometimes I like to go over this just so you can see the interface, so when you get there, it's not as disconnected. This is an example where it is a vertical stretch. So your x-axis is going to be the same, your y-axis is changing. So at -2, -4 becomes -2, -8. Right? 0, 0 doesn't change. 2 - 4 becomes 2 - 8. And then I can draw that from this 2f of x. 2f of x is different than f of 2 of x. So you have to be really careful what's being manipulated here. The y-axis is changing, the x is not being manipulated at all. I want to keep the domain the same, but the y is changing. So again, some reflections and shifts. Make sure you do any reflections first, then your shifts. Or you're careful with knowing you're shifting down to, and I'm reflecting about that point. But that won't necessarily work here. The last one is a last one like we did in class. We said we have this blue function. We want to represent this red function. What do I need to manipulate to get an algebraic expression for that? So be careful if I'm going to the left 3 units, the way I put it in here, since g of x, so I'm going to have to maybe open parenthesis, x -3, close parentheses, and then use the exponent for a 2 there. Question?
+3.
Yes, thank you, +3. Right? And then -2 there. So just on the input, you might have to use your parenthesis, and then x +3, close parenthesis, and then use your exponent of 2 there. Any questions? And that should be your homework. And exams will be very similar to your homework and your pie type questions. So if you feel comfortable with these, then just be careful that there's a little disconnect from doing on the computer and doing it by hand. But the idea is the exact same. If you understand where the points are coming from and not just getting lucky with the software, then you'll have no problem on the exam. All right, I will see you guys on Friday. Do you want to do a little quiz in class?
No.
A word together, graphing.
Work together.
Right, so I'll probably try to print something off and have it in class on Friday so you guys can get some feedback. So I can get some feedback of how you're drawing it, what you're interpreting, and knowing that. Graphing is not too bad, but when we get into some of the other like simplification, it's important to see that you're writing it correctly. So I will see you guys on Friday.
So I'm having the same problem she was, except